before we go to today's class, in our last class we looked at the properties of limits as the last thing that we looked at there. Now, for this property, the division property, this can stand if this denominator as x tends to a is not equals to 0. This can stand if this denominator is not equals to what? 0. Because if it is 0, our answer becomes undefined relatively. Becomes undefined. And finally, we also have one more. Limit as x tends to a particular point. Limit as x tends to a particular point of a constant. If you have a constant, limit of a constant, it is equals to that constant. Okay, so that's the last limit. Now, for example, we said compute the following. Number 1 is what? Limit as x tends to 2 of what? 4x minus 1, and so on. Now, before we solve, we have 4 methods of solving questions under limits. The first method is the direct substitution method. The second one is factorization. The third method is differentiation. And the fourth method is using L'Hospital's rule. Now, with this 4 method, you can solve any question or you can solve all questions relatively under limits. We're going to be going from the first, second, third, fourth. If I try the first one, it does not work. I'll try the second one. If it does not work, I will try this one. This one relatively always work. Then this one also always work. Now, when we're going to use them, it will be told us when I start solving these questions. Now, for number 1 question, I'm giving what? Limit as what? X tends to 2 of what? 4x minus 1. Now, let me try direct substitution. What direct substitution means is that what? Just put the value of this x, where your x tends to. It tends to 2. It means put x as 2, leaving my answer to be what? 4 into 2 minus 1. Gives me what? 8 minus 1, that is what? 7. It worked. So since it worked, then 7 is my answer straight up. Now, number 2 question says what? Limit as x tends to minus 2 of this. Now, this one I just solved is like the example, is the first property. It's like for the first property, where my L now is what? My L now is 7. For this number 2, it is like this second property, where you have to split it with their respective limits. That is, you can say the same thing as what? Limit as x tends to what? Minus 2 of 3x squared plus limit as x tends to minus 2 of what? 5x plus limit as x tends to what? Minus 2 of what? Minus 9. Now, from here, what do I have? Trying our direct substitution means you should put your x as what? Minus 2 in each case is where you see x. And for this constant, the answer is still minus 9. But now, on solving, what do I have? This now becomes limit of 3 into what? Minus 2 all squared. Okay, number 2 question. That becomes limit as x tends to minus 2 of 3 into what? Of 3 into what? 2 all squared. 3 into 2 all what? Squared plus limit as x tends to minus 2 of what? 5 into x, that is 5 into minus 2, then plus minus 9. Why? Because the limit of a constant gives me what? That constant back. So this should be out already. This should be out already also. On expanding, this becomes 3 into 4 plus what? 5 times minus 6 is what? Minus 10, then minus 9, which leaves me as what? 12 minus 10 minus 9. This is minus 19 plus 12. It leaves me as what? Minus 19 plus 12 gives me minus what? 7. Okay, in this case, my earlier is what? Minus 7. For number 3 question, Number 3 question says what? Limit as x tends to 1 of 3 into 2x plus 1. This is my question as x tends to what? 1. Now, as to my third property, I can express this as what? 3 times the limit of what? 2x plus 1 as x tends to what? 1. Try my direct substitution still. It means you should put 1 where you see x in this equation here. Or that function, I mean. That becomes 3 into 2 into 1 plus what? 1. Immediately I am putting your values of x, your limit does not appear again. Your limit disappears basically. So this now becomes what? 3 into what? 2 times 1 is 2 plus 1 is what? 3. So my answer is what? 9. So it means direct substitution is still working. Now then for my number 4 question says limit as x tends to 1 of what? X plus 1 over what? X minus 1, where x is not equals to 1. If I put x as 1 up here, this is 2. If I put x as 1 down here, this is what? 0. And I said my denominator cannot be what? Can never be 0. So it means I cannot use direct substitution. By direct substitution, my denominator will be what? 0. Let's try factorization method. It cannot work here. I cannot factorize anything here. This is x plus 1, this is x minus 1. So I cannot factorize anything here. Now, let's differentiate. Differentiating in limit means you should differentiate the numerator and differentiate the denominator. As you are doing for the numerator, you are doing for the denominator in this case also. So on differentiate, what will I have? That becomes what? 1 over 1. You know, if you don't know how to differentiate, you can check my videos on calculus. So differentiating this gives me 1 over differentiating this gives me what? 1. Now, 1 over 1 is now what? 1. It means the limit of x plus 1 over x minus 1 as x tends to 1 is equals to what? Is equals to 1. You know, if I try L'Hospital's rule, I'm also going to get the same answer. Okay, let me see, look for a question that can give us on factorization, where factorization will work. Limit as x tends to 1 of x squared minus 1 over what? X minus 1. Now, it is similar. What is the difference? The difference is that what? This is x squared minus 1. This is t x minus 1. In this case also, x here must not be equal to what? 1. Because if x is equal to 1, this is what? 0. How do I factorize then as my second method? How I factorize is very simple. Look at this. This is the same thing as what? Limit as x tends to what? 1 of what? X minus 1 times what? X plus 1 all over what? X minus what? 1. How did I get this? This is difference of 2 squares. If I perform difference of 2 squares here, I'm going to have this as what? X minus 1 times what? X plus 1. You know, which is the same thing as what? X squared minus 1. Now from here, what happens? This cancels out. I'm left with what? Limit as x tends to 1 of what? X plus 1. In which case, what that now happens? Using direct substitution now, you know, what will I have? 1 plus what? 1, which is equal to what? 2. So my answer is what? 2. Now, for questions like this, most times you might need to factorize. After factorizing the numerator, one of the numerator values will cancel the denominator's value, leaving you with the other side of the numerator. And from there, you can now do what? Direct substitution, from which you're going to get what? Your answer. Now, for L'Hospital's rule, which I've not used, I'm going to use it in my next video.